So what's the deal with MBSE? Basically, it's taking the traditional process of building complex systems and upgrading it with powerful digital blueprints. Instead of relying on scattered documents, we use these models to track absolutely everything, from what the system needs to do to how it's designed and tested. And we do this right from the very first brainstorming session all the way through the product's entire life cycle. In this video, we'll start by answering the most fundamental question: what exactly is MBSE? Then we'll dive into the pillars of MBSE. Think of these as the essential building blocks that actually make this whole model-based approach possible. Finally, we're going to bust a common myth that's been floating around about MBSE. It's important to keep our expectations grounded in reality so we can actually deliver on the real value and return on investment that this approach promises. Let's dive in. So what exactly is MBSE? To really wrap our heads around this approach, it helps to first look at the alternative. Industry pros call this alternative the document-based approach, but most folks just know it as the way we've always done things. Here's a little secret. Whether teams are using that old school document method or the modern MBSE way, systems engineers are actually doing the exact same steps from start to finish. We are still following the standard lifecycle activities laid out by INCOSE, which just stands for the International Council on Systems Engineering. The huge difference between the two approaches isn't what the engineers are doing, but the actual stuff we produce along the way. Instead of churning out massive static text documents to track their work, we are building dynamic digital models. So what does this old document-based approach actually look like in practice? Well, it means engineers are stuck manually generating an absolute mountain of separate files. Just to give you a taste of what we're dealing with, first we have to handcraft things like ConOps or concept of operations documents. These are thick manuals explaining exactly how the system will be used in the real world. From there, we move on to requirement specifications. Think of these as massive lists detailing every single thing the system must do. But wait, how do we track all of those rules? We use tracking matrices. These are endless spreadsheets, often called RTVMs, created just to prove we actually tested all those requirements. Next up, we interface documents and charts. These are separate files and complex grids, sometimes called n-squared charts, that exist solely to explain how all the different parts plug into each other. Once we figure that out, we have to write up the architecture and design specs, which function as huge written blueprints of the overall system. Of course, we also need testing instructions, acting as step-by-step guides on exactly how to test the final product. And if that wasn't enough, we pile on specialty reports. These are deep dive analyses checking things like how reliable the system is, how fast it responds, or how much data it can handle. You get the idea. There's a lot, and it is an overwhelming amount of paperwork. So what happens when engineers use this old school method to create all those artifacts we just talked about? To start, it turns into a scattered mess because we end up producing a totally disconnected pile of text documents, spreadsheets, diagrams, and presentations. And to make matters worse, we also have to deal with scattered storage. This means we have to manage and store all these files across a bunch of different disconnected folders and databases. Now you might be wondering, what's the real problem with doing it this way? The biggest issue is that it is incredibly expensive. Simply put, the document-based approach costs way more money than it actually needs to. If you're asking why it's so expensive, it all comes down to massive maintenance costs. A huge percentage of a project's budget gets eaten up just paying people to constantly update this scattered web of files and make sure they all align. And if we decide to cut corners and not spend the money to maintain them, well, then everything breaks down. Our files quickly become inconsistent and entirely outdated, leading to massive errors and headaches down the road. Let's picture a realistic day-in-the-life scenario to really see how frustrating this old method gets. Imagine our lead system architect is reviewing the project, and she decides to make a design change. To make things cleaner and easier to manage, she takes one big complex piece of the system and splits it into two separate, simpler parts. Because that original piece now has a much more specific job, it naturally makes sense to update it. To reflect that update, she decides to give that original piece a brand new name to perfectly match its new, narrower focus. So she's made a smart design choice, but what does it actually take to put that simple name change into action across the whole project? Well, first she has to go on a massive scavenger hunt. She needs to track down every single text document, table, spreadsheet, diagram, and presentation that even mentions that old piece of the system. And unfortunately, finding them all is only half the battle. Once she tracks them down across a maze of different company servers, websites, and complex storage databases, she has to open each file up one by one. And the kicker? She has to manually type that exact same name change over and over again into every single one of those scattered files. As you can imagine, doing things this way is incredibly time consuming and highly prone to errors. For starters, it's too easy for our architect to just accidentally mistype that new name while she's manually updating everything. But a simple typo is just the tip of the iceberg. The much bigger issues that she actually has to know right from the start every single file that needs changing. Since there could be a massive amount of them, she's almost guaranteed to miss a few. When that happens, those forgotten files are suddenly and totally out of sync with the rest of the project. And that inconsistency causes a major domino effect. The development teams further down the line are relying on those exact documents to do their jobs. If their instructions are outdated or contradictory, things are going to break. Which brings us to the absolute nightmare for the project manager. They are the ones who have to step in and deal with delayed schedules and skyrocketing costs just to go back and fix all those mistakes that snowballed down the line. Sadly, this messy scenario happens all the time in projects that are still stuck using that old document-based method. The root of all this pain really comes down to one word: inconsistency. And that is exactly where model-based systems engineering, when done right, steps in as the ultimate solution. Now let's look at how the MBSE approach completely flips the script. To start, with MBSE, our engineers are still doing the exact same work and delivering the same final products as before. But here's where things get really interesting. Those final documents aren't the main focus anymore. Instead, the real star of the show, the primary artifact, is one unified, consistent digital system model built inside a dedicated software tool. So what happens to all those massive piles of separate documents and charts we talked about earlier? They become totally secondary. All those extra files are just generated automatically right from that single central model using the software. And this central model acts like a giant, super organized brain for the whole project. Because it acts as a single source of truth, every single design choice or change is stored as a piece of data in just one specific place within the model. Which brings up a really important distinction. Any diagram, spreadsheet, or text file you look at is just a view or a quick snapshot of that underlying model. It is not the actual model itself. And why does that exact distinction matter so much? Because that single difference is the entire secret behind why MBSE saves so much time, prevents those snowballing errors, and delivers an incredible return on investment compared to the old way of doing things. Let's jump back into that day in the life scenario we talked about earlier. But this time, let's see how it plays out using the modern MBSE approach. Just like before, our system architect decides to rename that original part to better match its new specific job. But here's the game changer. To make this update across the entire project, she doesn't have to go on a massive scavenger hunt. Instead, she just uses a quick keyword search in the modeling software to find that one specific part, types in the new name exactly once, and that's it. She is completely done. Now you might be wondering, what happens to all the other places that part is mentioned? Well, the modeling software automatically and instantly updates that name on every single diagram it appears on, no matter how many there are. Remember, those diagrams are just snapshots of the central model. So when the core model changes, the diagrams change instantly. And the magic doesn't stop at just the visual diagrams. The software also automatically updates all the written documents the very next time the architect exports them. Because everything's linked to that single source, there's literally no chance for mismatched information or inconsistencies to sneak in. Which brings us to the real superpower of MBSE. This approach guarantees better quality and saves a ton of money for one very simple reason. The absolute cheapest mistake to fix is the one you prevented from happening in the first place. And sitting right at the heart of all this success is that incredibly powerful system model. Now, as a quick side note before we move on, the specific workflow I just described is actually a bit of a hybrid approach. It acts as a perfect bridge, helping teams transition smoothly from the old document-based world into the full potential of MBSE. Now, I mentioned just a moment ago that the workflow we just looked at is actually a hybrid approach. A lot of engineering teams have to use that hybrid middle ground simply because their clients still demand old school text documents for their final review and approval process. But what happens if a company doesn't have those strict client rules holding them back? Well, they get to practice MBSE in its purest form. When an organization reaches the absolute highest level of MBSE maturity, they skip creating traditional text documents entirely. The digital system model itself becomes the actual deliverable. It is the exact thing that gets reviewed, approved, handed off, and constantly upgraded as the project moves from one design stage to the next. And it gets even cooler for teams that are building software systems. If they use a powerful enough modeling tool, they can actually take their system model, transform it into a software model, and eventually use it to automatically generate real production-ready source code. When you reach this level of the process, the entire game changes. This advanced maturity completely blurs the old boundaries between designing a product and actually building it. It empowers teams to create rapid prototypes and run realistic system simulations faster than ever before. But through all of this rapid development, one golden rule remains completely unchanged. The central model is always the primary focus. Whenever a customer changes their requirements or a new design choice is made, the model is the only thing that gets modified. Everything else, including that final source code, is just an automatically generated byproduct, perfectly and continuously in sync with the master model. And folks, that is model-based systems engineering.